Good morning, everybody. We're starting a session on static analysis. My name is Marcia Chechik from University of Toronto, and I will be chairing this session. We're going to have a number of full papers across multiple tracks, including the technical track and seat, and then a couple shorter papers towards the end of the session, the last one being on Zoom. We start with DLInfer, deep learning with static slicing for Python type inference. And this is the Nanjing University talk with Yan presenting.
Hello, everyone. I am Yanyan. I come from Nanjing University. Today, I will introduce our recent work, DLInfer, deep learning with type inference, deep learning with static slicing for Python type inference. First, I will introduce the Python type inference. We all know that Python has become one of the most popular languages, and the variables are defined without a type declaration. So it's making it extremely too difficult to read and maintain. However, we can have many solutions, and we can have the type infer aims to automatically infer the type information of the program. For Python, the type inference techniques can be divided into two parts. The first is the unification-based. However, they may counter lack of source code of libraries and third-party cores. And the second one is the learn-based. However, they rely on a rich data set and can be divided into context-based and logic-based. But for Python, it's not easy to construct the data set. So, as for the learn-based technique, only LambdaNet combines by using the context in the dependence graph. What by this? We propose a method to combine the logical information into the context. We call this static slicing. Our DLInfer framework can divide into four parts. The first one is the data preparation. The second one is the static slicing feature collection, and the third one is the code slicing embedding. The last one is the model training. I will introduce this in the next slide. The first is the data collection. Although some existing research work provides the public data sets, however, after manual checking, we found that this data set does not directly use in our experiments because they are unable to extract the slicing information. And also, they may be unable to use the type infer tools. So we select 700 open source projects with type annotations from GitHub and use CD4PY to deduplicate the projects to delete redundant file information. The second part is the slicing extraction. Our goal is to extract the line code lines related to the variable location and their variable usage in Python modules. And we only focus on the, This is not the formal. We only focus on the global variables and the function parameters and the local variables. And we only focus on three kinds of variables. And our slicer can construct a dependence graph between the variable according to the data flow information in the module and the data use information. And for the function parameter, we only extract the function call. And if the parameter has no type annotation information, we ignore them. This is the sample of our slicing example. In this short code snip, we can see that the global variable relax cake and the function parameter and the local variable in function body. We extract the slices of this in the right picture. Then for the embedding, we use the unigram language model to convert the dataset into substrings to prevent out of vocabulary. And then we embed the substrings into the vectors through the word-to-vector. Then we employ these vectors as features and correspond to the variable types as labels that generated by applying the one hot. This is a workflow of the embedding, and this is the workflow of the UML. This is the embedding sample. We can see that the substrings following the underscore represent the beginning of the original word. That we can see that the defi or the validation, this can be started as the underscore. Then we train the model because we know that the code statement sequence is the type of time series. For Python, the type of information can be inferred from both forward and backward. So for the forward propagation, we can know that the variable definition and their usage of in the following languages. And for the backward propagation, we can know that is the return value of the function call. So we use the Jiahan as the training model to for use of the program slice. To evaluate our DLInfer, we propose 3 research questions. The first research question, we focus on the effectiveness of the statically collected dataset. That is, we collect these variables from the statically in the training set. We collect the type annulation and we use Python to statically infer the types of these variables. And the prediction dataset is the same as the training dataset. We only use the static collectly variables. In the second research question, we focus on the effectiveness of the dataset obtained by dynamic analysis. And the training dataset is the same as the first research question. And the prediction dataset is, in each project, we collect the variables and by running the test case in the project. In the third research question, we focus on the effectiveness on datasets obtained by dynamic within one project. That is, we use the training datasets as in the single project without the rich type of dataset. And the prediction dataset is same as the second research question. And we can see the dataset in detail. We can see that according to the Python manual, we can divide the variable type into 3 parts. That's the built-in, such as int and string, and the user-defined, that's the classes we defined, and the third is the library, such as the external library type. The status of the dataset are shown as the 2 tables. As for the baselines, considering the open source projects relying heavily on the third-party library.
Can talk after the end of the session. We're now.
Good morning, everyone. My name is Zhang from AWS AI. Today, I'm presenting a paper called Long-Term Static Analysis Rule Quality Monitoring using 2 negatives. It is a collaboration work with Linghui, Rajdeep, Umar, Martin, and Daniel. Okay. So first, let me introduce what is the Code Guru Reviewer. Code Guru Reviewer is our service. We use the program analysis and machine learning to detect bugs in the code. Typically, it is used in the code review time when you do a pull request to submit a code review. We will post this kind of recommendations, such as shown on screen. But there's other ways to use it, like offline package scan. And for this particular example is about security funding. it is suggesting that, okay, currently you are using a HTTP URL connection, but it's not a security URL connection. So it sounds like it's a good finding. But story is always complicated. Even for this security finding, looks like a very good finding, but sometimes it may not be totally actionable. Why? Because fix may be outside developers' control. Maybe it's a legacy part of code. It's some team standards. They're using this kind of, instead of using a security connection, but using this connection. And the most important thing is we want to catch the behaviors, catch the healthiness of our rules. Imagine we have hundreds of such rules, and we want to monitor its behavior on a daily basis. What do we need? We need a metric that's going to give us the information. So before talking about the metric, let's say what kind of quality of the metric, what's the criteria we want to looking for? What is a good metric? First, the metric has to define the usefulness to the developer. And the usefulness is about, okay, if the developer thinks this recommendation is correct or not. The next level is the recommendation is actionable, whether the developer go ahead and fix the code. And in the next level is basically whether the developer actually learns something. And in the future, in the same situation, they avoid making the same mistake. So this is the usefulness of the developer, for the developer. Second, the metric also has to help us to identify the changes of the rule that impact the quality. Because this is kind of, we manage the hundreds of the rules. And different teams or different individuals contributes of them. And we need a centralized place to identify the changes of these rules so that we can prioritize the rule improvement, also identify the rules that's no longer relevant. Now let's look at some of the very commonly used metric. The first one is a number of findings. This is everybody uses for this kind of tool. And it actually measures how active the rule is. And here we show the 3 simulated kind of rule scenarios. The rule 1, rule 2. First, let's look at rule 2. Rule 2 is a flat curve. Across the time, the number of detections is a keep constant. And be aware, the number of detection could be up and down. The curve, the flat curve can move up and down for different rules. But it doesn't necessarily mean that a very frequent detection is better than a less frequent detection, because it all depends on the nature of the rule. Some of the rules, like log injection, is by nature more frequent. Some of the rules may be more security related. Let's say it's encryption of a special API, and this is more naturally to be less frequent. So the flat curve doesn't tell you a lot of information. Interesting thing is about the change of the curve. Let's look at the rule 1. The rule 1 is we're starting from some number of detections, and the detection actually, with the time being, is climbing up. So this is likely to be the scenarios that there is introduction of a new API, introduction of a new framework. At the beginning, the adoption of this framework is not so popular, but with the time being, it's becoming more and more popular. So this is kind of scenario. And there's also an interesting scenario for rule 3. Rule 3 means initially the finding is a lot of findings, then the finding goes to drop, and eventually maybe it's kind of go to 0. So what kind of scenarios about this could happen? There's a bunch of things could happening. So using the single metric cannot tell it. But I will tell you one story about what's potentially be a good thing. Initially, we have a lot of findings. The developer learns how to fix it. Then in the future, they stop making such mistakes. So this is why the number of findings drops. And eventually, if it is saturated in a non-zero place, it might mean there's some legacy code. There's some of the very difficult to fix scenarios that because of the context change or configuration change associated with it. So reflecting the criteria we're trying to satisfy. So using this number of findings, we can actually quickly identify the change of the rules that impact the quality, because the change of the curve of this kind of number of findings tells us there's potentially there's a change of scenarios. And also it can help us to identify rules that's no longer relevant. If the number of findings keep on dropping into the 0, which means there's obsolete of API, nobody's using it, then we probably stop this rule as well. So next we talk about another very popular criteria metric. It's called the fixed rate. And this is one of the most popular ones. The fixed rate is great because it's measure the quality of the rule. Still, we're using 3 simulated kind of rule scenarios. Rule 1 and rule 3 are flat, and the rule 1 is kind of higher fixed rate. Rule 3 has a lower fixed rate. Normally, this means rule 1 has high quality than the rule 3. But the more interesting is about the rule 2. Initially, it has a higher fixed rate. Then the fixed rate can keep on dropping. And again, with this metric alone, you cannot get the whole picture of it. And maybe a good story of it is, as I mentioned previously, initially people learn how to fix it, then people stop making mistakes. So if we look at the number of detection at the same time, if the number of detection also drops, it is a good thing. Because people learn and the number of detecting drops, the fixed rate drops, there's something that they cannot fix, keep them constant because there's some legacy code, there's some team standards, they avoid changing the code. Again, what the fixed rate can deliver for our quality. So basically, it can measure the usefulness to the developer. Think about the rule and the rule 3, which rule is more kind of more high quality. And also, it can quickly identify the changes to the rules that impact the quality. But from these 2 rules, we already identified none of the metric can cover all the criteria we're looking for. Now, let's see what we're trying to propose. We're trying to propose what we call the true negative. Now let's move to what we mean true negative, because true negative is I would say it's a little bit miss of extension or using of the terminology. True negative in machine learning usually means in the ground truth it's negative and the model predict as a negative. But in our case, we using a similar fashion of way, but there's a little bit of change of the definition. So the true negative means the code is still relevant and the developer actually doesn't make mistake on it. So basically, it's a good thing. So for this particular example, also sometimes we call it compliance, non-compliance code. And this particular example is about XML, XML entity injection. And this is a security rule. And for the true positive, which is actually the non-compliant code, we know that for this particular document factory setup, we need to set up a bunch of properties to avoid safety issues. And the true positive, actually, it's a mistake. The rule will highlight because you miss the one setup of one property. The true negative is actually a good thing. The developer do not make mistakes, and this is a good thing. So true negatives catch some of goodness of the behavior and what exactly it is. Now look at a little bit the simulate again 3 type of scenarios, and this time the curve looks much more interesting. So rule 1, rule 3 have the same issue. Let's talk about the rule 1. So initially, true negative is low, and this corresponds like initially the developer does not have the knowledge about this type of the bug. Let's say they don't know about the XXE injection, and they make mistakes. Then they learned how to fix it, and from the time being, they avoid making the mistakes, but their code base is still related with this XXE case, and the true negative number goes up, which means they are doing very good. And they learned to avoid mistakes. And compare rule 1 and rule 3, what does it mean? This is comparison of the rule. Just means the rule 1 is more easier for the developer to acquire the knowledge, to make the fix, to avoid the mistake in the future. Rule 3 is a little bit more challenge. Maybe we need to improve the message, maybe we improve the wording of that so that let the people understand how to fix it. Or maybe it's natural of the rule because this is a hard-coded secret. In order to fix it, it involves a configuration change, involving other frameworks using like AWS Secret Manager, all this stuff, involving not only the code change, but the configuration change as well. So this is actually tells you the difference between the rule and the rule 3. But for rule 2 is a little bit alarming. So initially, the developer actually did not make as many mistakes as when the rule, when the time being, which means there is a changing in the rule, and that change actually did not perform as well as it's intended to be, and maybe because of the changes kind of missed something, or maybe it's because of the wording something. So this is alarm that we should be aware, and when we see that kind of signal, we will go back and see what's the change of the rule we made and why it happens, and we want to fix it very quickly. So go back to the criteria page, what the true negative give us. It helps to measure the usefulness of it to the developer. It helps us to prioritize the improvement. Let's say if I see the curve of root 2, I will immediately jump on it to fix it because it's just alarming. And also identify rules that's no longer relevant. And the best thing of them using this rule quality to throw two negatives, it's a good indicator if the developer wants to learn of learning something, allows to compare rules, provide indicate if rules still relevant. And now if let me take a summary of the metric. We talk about the number of findings, fixed rate, number of findings plus fixed rate, and combine with the two negatives. So combining with true negatives with the number of findings, fixed rate, gives us a complete picture. It allows us to learn whether the developer actually learned something, whether allows to learn that whether this is kind of a legacy code that they cannot fix, all these type of informations. So this metric combined together deliver the best message we have. So what's in the paper? We have a very quick summary, high level, about what we're trying to deliver. And in the paper, there's more examples, and there's deep dive on user studies on 4 rules, as well as more observations in the metrics. So please read the paper, and I think we get some time for the questions. Thank you.
Time for one question, maybe? Go ahead. Up. Into the mic.
Thank you for an interesting talk. I would like to know if you could elaborate on some sample rules that you are using and how do you measure them that these are the quality impact? Are these measured by BMD or SonarQube, or do you set up those rules internally? So could you elaborate on this a little bit?
I'm going back to this slide. So these are all the rules we have is external. So basically, CodeGuru is an external service, just like SonarQube, and you can subscribe it. And this is particularly, when you subscribe, it will give suggestions like this. And we have hundreds of such rules, and a lot of them are related with security, and a lot of them are with AWS best practice, which is kind of unique to us because it's AWS, and also a lot of good stuff. And you can check out our our service online, and I can connect offline and give you some more information.
Thank you.
Thanks.
All right, let's thank the speaker and move on.
Thanks again. And it's not here. Oh, it's here. Okay. And I'm presenting this paper, Language-agnostic framework mining static analysis rules from code changes. And I'm representing David, Burke, Rajdeep, Juan, and Omar to present it. And as Martha mentioned, David is also here. I cannot answer some hard questions. He will jump in. And previous talk, we talked about how to manage the rules because we have hundreds of them. But as a service, we want to expand our rules, scale out rules, and thinking about how to write the rules. Typically, this is a kind of domain expert. You have to be familiar with the language. You have to be familiar with the scenarios, like certain type of security scenarios. So you write the rules. But this does not scale so well. So what happened? What we're proposing right now is basically we're going to using a data-driven approach to do that. So we call it kind of language-agnostic change code mining and clustering framework. And it's divided into 2 major parts. First part is mining. Second part is the clustering. I think previously the second talk is also talk about how to track the version set, changing code mining about it. And so this is kind of relevant. Change code mining. So code repository contains a lot of information. And what we do is basically we find the difference between different versions. And we find the corresponding functions, procedures between the version 1 and the version 2. And we represent it into a language-agnostic representation. And we call it mu graph, and I will talk about in the next slide. And once we have this correspondence set up, we do the graph differencing approach to find what is the changing part. So we get the change of the graph. So this is basically the high level of the code change mining. So the next is about thinking about the package contains many files, contains a lot of functions. And the original analysis is basically finding the corresponding method in revision 1 to revision 2. So talking about the same thing, but they're different. We want to match them. And in order to do so, we said we represent them as a graph. And this graph representation is called a mu graph. It's called a language-agnostic representation. Mu graph is a technology basically corresponding to a date-dependent graph overlaid with a control flow graph. And how are you going to do this origin analysis? Basically, it's kind of quite intuitive. You starting from the package, you find the files, you finding the corresponding method, and you have to match the type, match the variable, match the fields, and do this kind of recursive or the breadth first tree level until you find the matching methods. Once you find the matching method, the next step is kind of extract the difference. And the difference is not simply the code difference. We're using just the text-based code diff. It's about the representation diff. As mentioned, we're using the mu graph, and it's a graph differencing algorithm. And that's the essential part. You represent what's the change. And here I give we give some very simple well, I'm sorry, it's not big enough to read everything, but what it means is kind of highlights how we do in the graph alignment. There's an out loop and there's an inner loop, and the code change is about, we changed a little bit of the inner loop, modifying here and there. So in the out level, the alignment is pretty straightforward, everything aligns well, so that's the part, there's no change, very clear. And in the inner loop, you see that there's something changes. And the graph different algorithm is trying to get what's the change of the graph. But in order to make it work better, there is type resolution problems. As I mentioned, if you want to match the entity well, it's not only about the method name, it's about what the method is about, what's the return type, what's the parameter type of the method, so that it can match well. Because you can have multiple methods with the same name. And but for dynamic languages like Python and JavaScript, it's not an easy thing. I think the second talk in this, the first talk is about how to do this type resolution in this session. And this is a well-known problem. And using the pass along, it's in our particular case for the JavaScript, it's recovering 12% of the types. And using our language-agnostic mu graph representation, it helps another 13%. And we have some of the innovative idea using the probabilistic inference network, inferencing to figure out another 13%. What it does is intuitively, we build a knowledge base. Basically, we mine the document, we mine the framework, Java libraries, everything. Ideally, you can think about when the developer writing something, you're using a variable name to correspond type. It typically reflects the intention, what is it to do. So basically, it's kind of using the similarity of the past experience. You see, this particular variable is corresponding to this, very likely to be this type, and using this kind of similarity like the reasoning, we call it probabilistic reasoning, to figure out another type. So we improved the type resolution by 26% using this kind of technology. So after that, we talk about the clustering. So here is something important to notice. As I mentioned, up to this stage, what we have is a change of the graph. And this is not the ready representation that you can throw into any of the clustering algorithm to work. So one choice is about, okay, how you convert into a numerical value to do the clustering, which you have a bunch of off-the-shelf clustering tool you can use. But that's not optimal. Why it's not optimal? It loses the information, human readable information on it. So what we did is basically, okay, for the change of the graph, we kind of represent it like this. Think about it. So this is the change of the graph. We have the node, we have the age, we have the what is the change of the part, and we also can assign the weights for the nodes on ages. And why this is important? This is because when you talk about the rules, it typically is about an API. Now for the API, it naturally forms a hierarchy. Why go directly for clustering is difficult, thinking about, and we are doing this on millions of this kind of code repos. And there's millions of such change graphs in this vector form you want clustering. It's very, very difficult. With this hierarchy architecture, by talking about the domain, by talking about the types, also by talking about the functionality of this method API, and within this leaf node, it reduced the number of the samples in each leaf node about 100, maybe even less than 100. Then the clustering becomes easy. And also, more importantly, it allows you to manually review. This is about this API. This is about this API interaction with another API. And this age is about definition age. And this is the change. Why this is important. And eventually, that helps the human in the loop to create a rule about it. And we follow this procedure. And this is the experiment, or this is the result we get when the paper was written. Using this framework, we actually come up with 62 rules, and 42 from Java, the rest of them from Python and JavaScript. And we put these rules in the real production in our system, and the acceptance rate for them from the internal developer and as well as external is about above 70%. So this is actually, we consider is a very successful way of from the data-driven way to drive the rules, and eventually we find these rules and to put into production. So here is an example of the rules. One of the minor rules. It is about AWS S3 client, but if you are not familiar with AWS S3, it's fine. It's basically the rule is about set up the retry limits on it, and it is kind of not like a lot of people can know about that you have to do this as a best practice, but the code change patterns from this clustering tells you that there should be a rules, and this rule works very well. Now, come to the conclusion. So today we presented a framework for learning static analysis using code changes and using a language-agnostic code change extraction and a clustering framework. And everything we talk about deployed in a cloud-based static analysis, Amazon Code Guru Reviewer. And our present solution actually scale up to multiple languages because of the language-agnostic representation we use, the mu graph, enables robust type resolution and infers domain-specific rules. Now, come to the questions. Thanks.
Thank you for the talk. It's super interesting. So my question is, could you please further a little bit, elaborate further, about the categories of code change patterns that you can mine using your technique?
So basically, one thing is that we try to avoid is something like refactoring, but when we look for what to mine, it was best practice rules that were explained, but also vulnerabilities. But it sort of comes down to fine-grained code changes that take place within a single method. And that is mostly often likely was shown misconfigurations, but also certain things of misusing APIs that could also be a security vulnerability, a performance-related issue. And what you often see is a very small but common patterns that get clustered together. And that's the kind of rules that we detect. You don't typically find long data slices of interprocedural rules across method boundaries, because those aren't necessarily what we would call fine-grained code changes. But yeah, that's basically what we did. As you would read in the paper, these larger methods, larger differences, also very taxing with the ILP optimization problem. So it also helps to look at smaller changes because that was much simpler for the graph alignment as well.
Hi, thank you for your work and your presentation. I was really curious about specific things about on your work. Is that how is computationally, what are the resources to compute all the proposal to the human of static rules that you want to propose to a human reviewer? And if you thought to expand your work to in reality further improve so that a manual human review isn't even really necessary for at least X% of your findings. Thank you.
There is Pranav, I think, works in this automatic rule synthesis.
Yes. So basically, the human review is important to maintain the quality of the service at this stage. We do have another work, which we actually take this clean clustering, thinking about in the leaf node, there's only 100, maybe less than 100 samples. We cluster into 2 or 3 clusters. The clusters typically is clean. With the clean clustering, we can actually do the automatic synthesis. We have another paper presented last year. Sorry, I can give you offline what the paper name. But we do have a lot of, in the system, there's an automatic synthesizer rule running in our system right now. But this paper is about the clustering work and the changing mining work. And in the downstream, we do the manual review to create the rules. And we also do the auto-synthesis part to do the rules as well. Well, I would say that the resource is actually not as bad as you think. You think about it. For this one, there's a graph matching problem, and you're using the solver, integer linear programming solver. Typically, it will be a kind of a very, very kind of time-consuming. But because of the MU graph representation, it is actually highly condensed, and also it's kind of typically for our experience, there's normally within kind of 1 minute you can do this kind of generate a diff in the graph. So it's fast. It's much faster than we initially expected.
All right, I'm afraid the third question is not happening. Sorry, let's thank the speakers. We gotta run. This is
Thanks again.
Okay, hello everyone. My name is ViolationTracker and I am a lecturer at the University of Auckland. And today I'm gonna present our tool GradeStyle, which is a tool to automatically assess code style in Java assignments. So we all agree that code style is important, especially for novice programmers, because it's better that they start to write good code from the beginning. But we also know that it's very challenging, because if we have large classes of students, we cannot manually mark 300 assignments, right? So this imposes a challenge. And also, most of us are using GitHub Classroom to deal with assignments, so it's important to have a GitHub integration. And there are some recent studies that show that existing static analysis tools like PMD and GradeStyle are not working very well in an education context, because they are overwhelming for students, there are too many warnings, and also they are not easy to translate violations to a mark, right? To a code style mark. So we propose GradeStyle, which is a tool for Java, and we are following the Google Java style guide. And we are focusing on the most important code style violations, which are formatting, comments, private members, and code clones. And we implemented those on top of GradeStyle and PMD. But we also propose some new code style violations which are not detectable by previous tool. For example, we are analyzing the class names and make sure it's a noun. We make sure that method names are verb. This following the Google Java code style. And also we make sure that comments is no code. We also make sure that the comments are different from the code being commented. And also we make sure that they are not a string concatenation inside for loops, because we know that this introduces performance issues. And we implemented this on top of Java parser and with WordNet. So this is the overview of GradeStyle. It takes an input, the config file. I will show you later how the config file looks like. And it takes an input all the GitHub wrappers and will automatically analyze the wrapper. In a few seconds, we produce some reports that you can submit to the students, either as a mark or as a feedback, right, before the deadline. But also, since this year, we gave the chance to students to actually run GradeStyle whenever they like. And then with GitHub Actions, we can automatically create a GitHub issue. So this is the config file that I mentioned before. So basically, it's quite simple. The instructor basically is listing the violations that wants to check, for example, like method names, and then needs to say whether wants the absolute score or a relative score, which means that the number of violations is normalized by the number of methods in this case. And also the instructor has the freedom to choose how to give scores. For example, here is 2, 5, and 10, which means that a student will get maximum score if the students do 2 or less violations, got 2 score if it's 5 or less, and 1 score if it's 10 or less, and 0 score if it's more than 10. And this one is an example of the report. Here you can see only 3 categories, but of course you can enable all of them. And there is a link, and that link is a link to the GitHub repo. So if the students wants to know what was the mistake, what was the violations, the student will click into the link and will open the GitHub page of his repo and showing the exact line where the violation is. Do we evaluate our tool using last year assignments? And last year we had 4 assignments, assignment 1, 2, and 3, and 4. And here we are showing the average GradeStyle mark of the 320 students. And you can see that, of course, is increasing over time. And we show with the red vertical lines when we give the feedback, and it's increasing. But also, it's very interesting that actually the initial commits of the assignments were actually improving the GradeStyle, which means that hopefully students learn something and they avoid to make the GradeStyle violations in the first place. This concludes my talk, and if you are interested to use the tool, it's open source. Thank you.
We are right about pushing to the next talk, but any quick question? Go ahead.
So very quick question. So can the user customize these checking rules? Because you mentioned you have some maybe more like built-in rules for checking styles. So can I just customize anything new that is not in your system?
Yeah.
Before you reply, while there is a reply, can we try to see if the next person's Zoom is coming on? Go ahead.
Yeah. So the tool is open source, so it's possible to extend it, and also we make it open source so that we are.
So how easy it is? I mean, do you have like domain-specific language for writing the rule? I have to program maybe some Java code.
Yeah, some Java code. Yeah. Thank you.
All right, let's take the speaker.